folks. This is me, Vishwas Nair. I'm the host of this podcast. And Pritam, sir, is one of my most desired guests on this DevOps chat show because a lot of times, we just realize, okay, what can a developer do in the world of DevOps? But trust me, we in DevOps, we do both operations as well as development. We don't sit down and say that, hey, this is breaking and I call the developers. And over a course of time, there is a huge demand which DevOps has created in the world of data science, AI, ML, data engineering, and a lot of things. It's startups. We have removed the dev, AI, ML, and it's just startups. We are just doing the operations and we are just doing what it requires to deliver that product. And hopefully, I think, there's no better than Pritam sir to give you such great insights because he has worked in Java, Spring Boot, whatnot. Like, I'm very glad that he's there on the show, and thank you so much, sir. It means a lot when you are coming on my DevOps chat show.
Cool. So the pleasure is mine once again. It is great to be here on the show once again. Thank you, Vishwa.
So let's just start with this question. This world of DevOps is fine, but like data engineering is not yet been that well furbished in the market because everybody has a different definitions for it. Like, I just know that for sure. So what is data engineering to the world today, and how is it defining the problem statement for the world of the data science and the deep learning? So what is the impact of it when it comes to the data engineering influencing the world of DevOps, AI, or anything?
Yeah, this is, so you're right with your first question, the definition of the word or the term data engineering, right? So everyone has their own definition. And so we are, yes, of course, like as a data engineering, so we are solving one problem, but yeah, so we have got multiple definitions, right? So I'll try to share my thought about data engineering, right? So because, so once again, as a disclaimer that it could be different, with somebody else, right? So this is so my perspective of data engineering, whatever I have experienced till right now. So now I think the biggest problems of what we face is this, that so we have got a data explosion, right? So in the last 5 years, we have seen that we are producing a lot of data, right? And we need to actually derive insights out of it. So we have to provide insights to the company so that they can take decisions on the data, right? So why it is now? Is it like the data was not there earlier? Yes, of course it was there, right? But right now the explosion basically happened because of that we have different instruments, different ways to generate more amount of data. That is the first thing, that we have various sources right now, right? So right now we have introduced the IIoT, right? The industrial IoT. So by adding sensors, so we know how to read data from sensors, right? We know how to parse data from sensors, right? So right now, those all things have become a big contributor for data generations, right? And so now we have got data. So we have got a huge amount of data. So now we have to generate insights, right? So that's the final goal. So what we have to do in between, so we have to right now create a proper parsing, that we have to parse or read that data and then store the data efficiently so that we can perform some kind of insight operations. And we can create some kind of nice visualization for the leaderships of an organization, right? So now that's the part what it is called your data engineering, right? So any engineering, right? So say if you talk about any engineering, so engineering, if you talk about building a bridge, right? So building a railway track, what you basically do is this, that you engineer a solution. So you find out that how do you fit nuts and bolts, right? And how do you eventually create the structure? That's called engineering, right? By creating a proper architecture. So this is the data engineering stands for, so from the source to your destination, how do you define the journey of a data, right? So it starts from the collection of data from a source, and the source could be multiple source, right? And as I told you that the sources are increasing, so definitely the format of data is also increasing, right? So we are not just talking about some basic CSV, JSON, text, right? We are talking about unstructured data, complete unstructured data, where we don't know how to read the data, right? There's no schema available in the data, right? So that's the variety of sources what we have, right? So now we have to read the data, such kind of data, right? So we have to read data in a scale, right? So we're talking about data not in some gigabytes, we're talking about in petabytes, zettabytes, right? So we have to think about reading data in a scale, processing data in a scale, storing in a scale, right? And then you also have to make sure that you store the data in a proper or an efficient way, so that once you're querying the data, the visualization becomes also efficient, right? So this all entire process becomes data engineering for you. So that's the definition of data engineering, what I actually have experienced like in my 6 years of working in data engineering domain, right? And coming to your next question, I think you've asked me about how the data engineering is defining the problems, the problem statement for the machine learning, data science, and AI, right? So now, so this is a very interesting question, because nowadays, I have seen there is a kind of change of culture, right? So I'm talking about just 2 or 3 years back, when people are crazy talking about AI, right? Everywhere I'm talking about AI. But now if you see that the tone got changed and people are talking about data, right? So data engineering is at very high demand. Why? Because we have to understand that how exactly the process or how exactly the pipeline stands. That if you do not know how to read data, if you do not know how to process data, if you do not know how to store data, there is no way you can create your AI strategy, right? AI depends on data, right? In machine learning, data science, there is so one proverb, I mean, like, which I really always keep in mind, that data in is equals data out, garbage in, garbage out, right? So you have to make sure that your data which you are picking, that is of high quality, right? But how do you ensure that? That is your data engineering, right? And that is a job of data engineers, right? And this is one thing what I have learned from my experience. I have worked a lot with data scientists. I have understood their problem statements, so we basically work in an iterative manner, that we create data, we create some kind of structure and we give it to them, and they come back to us saying that no, it's not really helping me out to train my model, right? Please change this, right? And the change is another a big process, right? That we have to change the entire pipeline, maybe like one particular column that is like required, but to capture that column, it's a entire change in the pipeline, right? So you understand this, right? So I just gave you one very small example which I personally have faced. The data engine, the data scientist, right? So they need quality data. For this, if they want something new that is not available like in my data, they definitely have to ask the engineers, data engineers, right? So now you can actually understand that how data engineering is defined in the problem statements, right? The first problem statement is the quality of data. How do you handle the variety of sources? How do you handle the variety of formats? How do you store data efficiently, right? This is a very important problem, right? So what data science is not solving, that is being solved by data engineering, right? And then once you have that available, then you go for insight generation, forecasting, model training, model prediction, right? But those all can work once you have got quality data.
As soon as you told us, I got this instance of you be a software engineer with a Toyota mindset. That's what you should be. You should know
Exactly.
You should know how to automate at scale. It's like being the Henry Ford back again. Like his father was in watchsmith, and he was like repairing one watch, and Henry Ford was thinking like, how can I automate this entire repair process of 1,000 watches at one given point of time? That's the mindset that we need to be in. Yeah, that's true. But like, today we have that first introduction for the software engineering, like, hey, you need to know Java, you need to know this, you need to know that. But like, I want to ask you this one experience of like, what was your first introduction to the room full of people talking DevOps this, DevOps that? Because a lot of times when I hear this, I get amazing stories out from the different developers, different scientists, and different engineers. So what was your first introduction to the room full of people talking DevOps?
Okay, all right. So yeah, this is, I mean, I just have to go a little past. In my experience, I mean, I started my development journey 11 years back. Okay. So at that time, so DevOps were definitely, it was there, right? But it was actually not that properly adapted, like the way actually how we are doing it right now. Okay. So any new technology, any new, so practice requires time for adaptation, because so we have to understand about the new practice or new technology. And then we also have to understand the value, what it is adding, right? And we have to understand the pain point, what it is solving, right? So everything takes its own time for the adaptation, right? So when I started working on it, I learned about Jenkins, right? So like it's a so quite famous tool for the CI/CD stuff, right? So I think we all know about Jenkins. So that's the father of DevOps. That's what we call these tools sometimes. Right. So at that time, so when I learned about the DevOps, right, or the operation, right. So we used to have like two different team. Okay, so we have the development team separately and the operation team separately, right? And we had to work in collaboration that, so when like as a developer, so my responsibility is work on the new feature, work on the bug fixes and push my code into the repository or into any source control management, right? And from there, we have got a system that is built or a pipeline that is built, and that's basically being owned by the operation team, right? Where we are not responsible to write the operation part of code, right? So where we are writing on the Jenkins script, right, of probably building your project, either it's in Java, Scala, Python, whatever, right? So you're building your project, you're deploying your project into some server, and while doing this thing, maybe you're also integrating with a code quality analysis tool like Sonar, and eventually you're deploying it, right? And maybe like while doing this thing, you're also integrating some kind of monitoring tool, right? But me as a developer, we are pretty much chilled enough that, that's not my job. Okay, that's their job, right? That's what I personally have so I have seen, and I learned about the operations at that time, right? But slowly, so the culture was changing, right? That we don't want to maintain a separate operation team like that. Okay, so the developer and the operations, right? So when we talk about the DevOps pipeline, can be built by the developers also, right? So where, or either like it can be built by the developers, or so what you can do is like you can actually so have the team, and so we are working so with a collaboration, right? So not like the development teams are absolutely not aware of so what the operation pipeline look like, right? So maybe like the operation pipeline are written by the developers, and it will be maintained by the other team, but that's the way, right? So that's another cultural change, right? So I have gone through this change, slowly one by one, and then I also have worked in an environment where the operation team is not even sitting in my country. All right. So that's a big story that we have to work with a ticket management, right? So we use Jira and all. So Jira is a great product. So for the ticket management, task management. So where we have to open a task for them and they'll take care of it. That's another culture, right? Now with this cloud computing, right? So once we have started using cloud computing, or even on the on-premise, I'm seeing the rise of DevOps right now. Okay. So I would say from the last 2 years or 3 years, I'm seeing a big adaptation of the DevOps in the so in the organization. Why? Why? I mean, like, so I would say, like, so people are right now so understanding the benefits, like, of actually so including the DevOps, or integrating multiple parties into a same pipeline or into a same process. Okay, so when I talk about DevOps, I talk about development and operations. Okay, and so now we have one more new terminology which gets coined, is called Devsecops, right? So where we are also involving another party, that is security, right? The cybersecurity team. So that also we are trying to involve in the entire process, where we want to actually make sure that the security audit should be a part of the development lifecycle from the very early stage, right? Not at the very last, right? And then we also have got business ops, right? So biz ops is like a bit more generic term, I would say, like where you are basically trying to merge the business and the operations, right? And operations, I'm not talking about just the software development operation. The operations, like what you basically see in the business, right? So what we basically call as a SOP, or standard operating procedures, right? So that's also like one of the word that you might be actually hearing a lot, right? So nowadays we are talking a lot on ops side, right? So now, I mean, I just like give you a bit of background about, like how I have like so come across like and my experience of the DevOps, right? So yes, I think nowadays, so whenever I talk to people, I think the first priority what we give is like, how do you automate your deployment process, right? That is the first thing what we keep in mind, right? Or I would not say the first thing, or like few of the things that we keep on priority when we are deciding about, like, so if we are starting a new project, right? Or if we are trying to refactor the process of a project, right? So this is one thing what we definitely talk about, right? And so nowadays companies are focusing a lot on creating a complete separate division who will be basically taking care of the entire DevOps operation, right? And I think you would know, so there is actually one role that is being coined by Google, which is called site reliability engineer, right? So the SRDs are basically nowadays, so quite common in a lot of companies, right? And the primary responsibility of them is to make sure that how they can build the better automation process or a CI/CD process across the enterprise, right? So now the focus is
With a
not
lot
just
of
to,
incidents management as well.
with a
a
lot
lot
of
of
incident
incidents.
management also. Yes, exactly, exactly. So the focus has been changed not only for a service operation, but an enterprise operation, right? Not just to automate your IT services, but to automate your enterprise, right? So that's the change of focus that has been occurred. And I mean, I personally have seen this change massively in the last 3 years, right? I mean, like probably 3 to 4 years, and particularly after this pandemic, right? It really is in big boom when you don't have people, right? So if you do not have people, you need to make sure that you have proper automations in the line, right? So where you are not dependent only on people, but you are dependent on the process, right? And process not only just like helps you to work in a much smoother way, it also helps you to avoid making mistakes.
That's true, because in Six Sigma we have this concept called as overbearing and us as a reluctant team.
Exactly,
You
exactly,
can't
yes.
be an overbearing guy and you can't just say that I'm going to do this, but if you don't deliver it on the time, probably that's going to be the worst nightmare for a company. Tickets are
Yeah,
raised,
yeah,
but you're not just going to do that. So today
yes,
we have
yes,
that problem
right.
statement for sure. So what is it all about when we are approaching a problem statement today? Over a course of time, we have a different definition. We have a different process involved. Like every culture has its own way of working towards the problem statement. Like you can say HSBC has embraced serverless. What do you want more than that? Like that's a solid example of governance policy taken care to the fullest. Billions of dollars
Mhm.
of transaction happen there. And so what should be our approach in order to approach a problem statement here? Because a lot of times it's different approaches, different pathways, but they need to run the product at the end of the day. So
Mhm.
how should we approach it, and what should be our mindset before we just not hiring the team, but also when you're like thinking about like what should we priorly have a prerequisite and architect towards? That's my question.
I think, so what you're asking is like, what is the need of the hour to
In
take a
order to
right
approach that
approach
problem. Yeah.
to find out the problem statement, right? Or how to approach a problem statement, something like that, right? Okay, I got it. Yeah, this is a very important question, so trust me, I mean, I really like this question, and I just want to take some time more extra to give you some thought on this, because this is the most important thing in the industry right now. I would not say in the industry, but in the whole world right now. That how do we approach a problem, right? How do we find out how to solve a problem, right? So because we always talk about that we need problem solvers, right? We need problem solvers, right? But how a problem solvers really think? So that's very important. And so what is the need of the hour? So when we think about problem solving, right? So before I just like jump into my thought, I just want to share you one sentence. So this is a proverb, I mean, like, which I really like a lot. So it says something like this, that a problem well defined is half solved. A problem well defined is half solved. What does that mean? Because so this statement itself is kind of so much so interesting, because it says about a problem well defined, half solved, right? So the first important thing towards problem solving is defining the problem. Okay, identifying the problem, finding a solution to the problem, implementation, technology, this all comes afterwards. But defining the problem, right? So it's very important that you break down the problem, right? So Elon Musk always says about one particular thing. I love this guy, like why? Because he always says this thing, that whenever you have a problem, go for a strategy called first principle analysis. What does that mean? You break down the problem to the very fundamental. Okay, define the fundamental problem, then you build on top of that. So like, say, if I give you a small example, say that, so let's take a home problem, right? So the problem is not only in the software company, like it's everywhere, right? Say like in your home, you have a gas oven, right? And you're not able to see a good flame when you are so putting the knob at the highest, right? That's a problem statement for you. You have to define the problem statement first, that what is the problem, right? That when I'm turning my knob, the flame was earlier coming till 10 inch, but right now it's showing me 5 inch, right? That's called defining the problem statement. If you define the problem statement, you already have solved it 50%, because it helps you to identify the root cause and then eventually to to solve the problem, right? So in a problem solving, so we have got a cycle, right? And the cycle consists of few steps. So whenever we have a problem, right, the problem statement has been given to you, then how do you approach that, right? First, as I told you, that it requires identifying the problem or defining the problem. Okay. After this, the second step will be this, that identifying the possible causes of a problem, right? Then the third step will be this, that brainstorm the options, multiple options to solve that particular the causes what you found out. Third step. Fourth step will be select one option from that. Say if you have got 4 ideas that you have brainstormed, right? Take one of the idea. What do you think that could be having a potential impact, right? Take that idea, go for a small POC, implementation plan, right? Then you go for you create the implementation, you so execute the implementation, and then the last step will be the validation of your the implementation. The validation will be the phase where you will see like if your solution, so that so once you're done with the implementation, that's a solution for you, right? And then the solution, when you're going for validation, that's a test for you that if the validation is actually solving the problem or not, right? And that becomes another cycle for you. If it's not solving, go for the second idea what you thought, right? Go for the second cause that you thought. So this is actually a vicious cycle of problem solving, right? And trust me, so this is actually so that we really need from people, right? That I personally have seen a lot of people that I give them a problem and they only think about in one perspective, right? Say that I'm talking to a data scientist, right? And I give a problem. They always think about let's use AI, let's use AI, let's use AI to solve the problem. But it is not the case, right? Every problem cannot be solved with AI, right? So I always believe in this thing that that we should be a problem solver and not technology promoter, right? So like it's very important to solve the problem with whatever the implementation. AI is an implementation, right? That what technology you are using, you might be using deep learning, you might be using in deep learning, you might go for Keras, PyTorch. So what is that? A TensorFlow, right? So those are all the implementation. But like you have to first of all find out that how do you logically solve a problem, right? So this is actually the main thing about problem solving, that defining the problem and finding out the non-technical way of solving a problem, right? Then you find out the technical implementation of it, right? And when it comes to technical implementation, it could be anything, right? It is not just we have to be, so there are like few other things that I personally have learned from the leaders. So I actually spoke with a lot of leaders, like the IT leaders, right? The technical leads, architects, the CIOs, CTOs, a few things that I personally have learned from them, that how a leader solves a problem, a technology leader solves the problem. Few things. First is that they are very clear on their communication, the transparency on the communication, right? So whenever you get a problem, be clear to communicate the problem down your line, or like to your stakeholders, right? Or to your entire team. Be very clear on the communication on the problem statement. And then you have to break down the silos. They told me about one thing, that like in your team, in your company, if you have got a silo of people where they do not know how to interact with them, a problem cannot be solved. So if you have got a great Python team, so who are super good in Python, and you have got great analyst team, right? But they don't know how to interact, right? You cannot solve a problem. You need both the skills to come together and probably think about a solution. So silos are not something that that we want in an organization, and that's the reason that you might see a lot of companies, they try to break silos. They do a lot of activities to make sure that the teams interact, right? So cross sharing of ideas, a lot of initiatives that the leaders are taking. Another thing is this, the open-mindedness. It is very important. So you should be having open mind, or openness, like so when you are solving a problem, right? Do not just strict or restrict yourself towards something. Like as I told you, like if I talk to data scientists, any problem they'll think about, let's use some kind of supervised learning, let's use some unsupervised learning, reinforcement learning. But that's not the case, right? That you have to be a little bit open when you think about a problem, right? So let's think about the entire scope of it, and then let's see like what is the right solution for it, and not just what I know, right? So that's the reason like the leaders, they always promote be open when you're going for problem statements, or so when you're trying to solve a problem statement, right? So these are the few things like what I personally feel that this is the need of the hour today. So when we are talking about solving some complex problems, right? So how do you deal with the problem? How do you start solving a problem? And how do you eventually land up a solution, right?
That's true. This is the ultimate proof that there's no defined culture for your problem statement. There's no defined path for your
Yes.
problem statement. Probably you might be using Jenkins Circle CI is good enough. Like some people have
Yes.
Azure DevOps Complete built on it. Like it's an end-to-end
Yes.
DevOps thing. It's a SaaS-based application. Just use that. You're good enough, but pay them. You need to
Yes.
pay them for
Exactly.
sure. So it's all about that.
Exactly.
Like how do you really infer that entire infrastructure, which is being in your hand, and how are you just moving that entire infrastructure to a secure environment and everything. Like we have observability, we have distributed tracing, like these are log data, right? That's what data is all about today. It's all that log that we are just creating. It's all about the
Mhm.
security, the governance, and the policy that we are trying to automate. So now when we think of data culture, which is evolving in the world of DevOps, it's huge because we are now pioneering a way in which we are trying to automate everything with a sustainable market shift. We have shift left, security shift left, so on. We have a lot of things coming up in the market. So, what is it all about when we are talking about a data culture, which is evolving every single day, and it's finding the way towards the DevOps? Because we still get the data from the logs that we create. We still have the artifacts and CVEs and data. By the way, some people are still researching on it. There are tools like Zeek, which can be used in collecting data of your network packets, like not even network packets from your protocols at least. Amazing set of tools. So what is it all about when we are pioneering a data culture for the DevOps world that we are trying to implement? Like nobody is DevOps complete or an enabled institution today. But like what is it all about when we talk about that data culture having an influence on the field of DevOps?
Yeah. This is a very interesting question, so now I think so we're talking about DevOps, and as in the very beginning, I just told you that. So we have increased the emphasis on the operations, right? So so what do I mean by that? So you take any field, right? So we have some operations where we have to do, right? So if you talk about AI, machine learning, data, uh, simple development, right? So we have got all these terms that we are hearing now as DevOps, MLOps, AIOps, right? So similarly, so when we talk about data culture, right? So like it's more about how do you create your enterprise level or maybe a project level data pipeline, right? And how do you implement DevOps, so which would eventually so create a process and also eventually reduce your development cycle and maybe will create a better pipelines, right? And that particular so that particular term is being given as data ops. So this is some fancy names. I mean, I really like these names. So what is exactly a data ops? It is actually an extension of DevOps once again. So which we are basically using to automate data pipelines, which is like eventually being used by the data engineering team and data analyst and all, right? And right now, the culture of data, the data ops as a culture is also quite popular. Why? Because we have to create pipelines, right? And we have to create robust pipelines, right? And as we know that what happens in any traditional DevOps, that we have a CI/CD process, right? So we have got a CI/CD process, and we also include the monitoring in that, right? So it is exactly applicable in the data world also, right? So in data world, what you can think of, right? So I mean, I explained you about data engineering. So where we have got a source of data, that where then we process that data or we stream that data from the stores, like in a real-time way or a batch way, whatever the way of how we are sourcing it. And then eventually we are processing that data by using some kind of code, right? Some kind of program, right? By using whatever language. And then eventually we are storing that data, right? And then maybe we are also doing some kind of quality check in the data, and then eventually we are storing, and then that particular data is available for the further use by analyst or maybe by other team, right? So this entire pipeline, right? So this is a pure automated process, right? And this is the culture, and the culture says this, and this so this operation or this process says this, that how efficiently you can bring automation in this process, like where if there is a change that you have to do, right, how quickly you can make the change and how quickly you can actually just apply the change in your pipeline, right? Like the example I told you in the very beginning, right? Like when I was working with a data scientist, they came up with the requirement saying that I don't have this column, I need this column also, right? So how difficult is for me to make that change available and give it back in the pipeline, right? That's exactly called automation, right? So like, I mean, I don't actually have to, bother too much, like in terms of like how I will write the code, how about the quality check, like if I'm asking for new data from the data source, how do I make sure that the quality of the data should not be impacted, right? As it is a new column I'm adding, right? So how flexible your pipeline is to add a new column or to go for schema less, right? That's exactly your the automation process, right? And that basically defines that how well you are in handling any change and how well you are handling the changes and how fast you can provide the change in the in your environment, like so whatever environment, like the staging environment, production environment, whatever, right? So this is actually the process, I mean, like what we basically call as the data ops, right? And in DevOps, right? So one more like a small difference that I want to share. So here that so when we are calling this as extension of DevOps, right? And so in DevOps, we know that the basic parties which actually plays a role, they are software developers, the QA guys for testing, and the operation team, right? But when we're talking about the data ops, right? So when we're talking about creating an automated pipeline, so who are the parties? You have the data engineers, right? You have the data quality engineers who are so trying to make sure that you have got right quality of data. It can be sometimes done by data engineers also. You have got data integrations, right? How do you integrate data? Okay. And then you have got data security, the GDPR, right? So this is the four stakeholders who basically comes into the data ops, right? So if you create a Venn diagram, right? So there's four as parties. So where they are joining, that's exactly what we're calling it as a data ops, right? And the DevOps is actually, so where you're involving the developers, testers, and the operations, right? So just like have this difference that in this thing, we do not have any operations as such, right? So because we are creating a pipeline and so the majority of the role are being played by your the data engineers. So because they can actually make sure of the data processing, data quality management, and also the data security, because that is also important because so when we talk about data, it's very sensitive, right? What you're capturing, what you're processing, what you're storing, these all things we have to keep it in mind, right? Where you're storing the data. So if you're storing data in US, right? So we have to think about the country policies also, right? So there are multiple things comes into picture when you're building a data pipeline, right? That's the reason data security also plays a very important role in data ops.
Yep, that's true. Yes, because over a course of time, there can be hundreds of things which will be coming up in the market, like as a product, as a DevOps tool, paid, unpaid, free and open source. All these are here to solve a problem. Like you want to write that shiny looking Linux command, no matter what. You're just going to define that. And that's what DevOps is all about. It's like,
Yes,
how can
yes,
you really
exactly.
get everything at scale, which is at a reliable form factor? Because you can't go out like, hey, I just installed this software on my production environment, like sudo apt-get update, and it got chaos. It's not like that, it
Exactly.
requires a lot of guts to do that, on the production environment and things like that. So now
Exactly, you're
when we
right.
are thinking,
And you
yeah,
know what? And you know what? So that is the reason. So like why we sometimes call it as a. So this is a culture, right? Why? Because a team cannot make this happen. One team cannot make this happen, right? So you have to make sure that your entire organization is looking towards this, right? So because these parties, as I told you, right? So we have got data engineering, data security, data integration. They are all different teams. In any corporate, you will be seeing like they are all from a different projects, so different departments, but they're all working together in a single pipeline, right? That's the beauty of DevOps, right?
yep.
DevOps or data ops, whatever you call it, but that's the beauty of this, right? That you're integrating multiple stakeholders in a process to achieve one goal.
That's true. That's true. That's what DevOps is all about. So now speaking about chaos, every institution has really faced this once upon a time, or else they face it every single day. So what is the perception of an chaos in an organization, and how do they learn from it? Because over a course of time, we didn't know that Log4j will be that big, but Log4j was amazing. Of course, Apache Struts, we have seen how Equifax SolarWinds got hit by it, and amazing CVs were raised, they were being solved. And for a fact, I was very shocked when Log4j vulnerability was solved within 2 days. And Maven had that post on their LinkedIn saying that, hey, we have solved the Log4j vulnerability. You're free to use Maven right now. I'm like, oh God, this is at the scale development that is going to happen. So now what should be an organization's perspective towards chaos, and how do they need to perceive that? Because a lot of times chaos defines what's your DevOps culture is. Probably if Netflix had not experimented with their Java server, then moving ahead with the EC2 instances and everything, probably they wouldn't have written that pioneering history in the world of DevOps. Like EC2 outage happened, but never Netflix was still working. And DevOps team still proudly says about like, what did we learn from AWS? Like by using AWS, 5 things we learned from AWS. That's a truly unimaginable thing. So what is it all about when we are perceiving chaos, solving the chaos in an organization at the scale, at the massive, reliable mindset in the mind? Like it should be more reliable for entire team and at the structure that we are talking. So what is it all about when you are speaking chaos?
I mean, I personally would say that chaos is needed, So if you do not have chaos, you cannot progress, or you cannot transform. Okay. So have you heard about that statement of the proverb, which is called necessity is the mother of invention?
Yes. Right? You have told it in my previous one also.
Yes. Yes. So now, so with chaos only, or with problems only, we learn, we try to transform, we try to change ourselves, we try to fortify ourselves, right? So because so if you talk about any product, right? Any product, I'm talking about just the software product, any product. If any say manufacturer are telling that my product is super secure, that's a myth. It's not possible, right? At a first go or at a second go, probably that you are releasing some say 2 or 3 versions. It's not possible to say that my product is 100% secure, that there is no security loopholes. It's not really possible, and that's a myth if someone if someone is selling it, right? So because there are people who are always exploiting the loopholes. They're trying to find out that like how to hack systems, right? Any systems, right? So that's why I personally would say that chaos are needed, because yes, of course, the time when we have it chaos at that time, so this is actually quite a difficult time for any organization to adapt to that, or to accept it, to fix it, and to move forward, right? So I think the example that you gave about the Log4j, right? So that was actually a pretty critical vulnerability. Okay, like so particularly for the systems, those are mission critical, right? And particularly for banking systems. And I think so you would know that the banking system, majority of the bigger banks, they are using Java as their backend, right? And Log4j is one of the tools that is being used for JVM platforms, right? And that was a big vulnerability. We never thought about that the vulnerability that we found out, it could be ever a vulnerability, right? It is good that the fix was being provided by Apache as soon as possible, right? And so when the problem was being highlighted, we also know that what is the backup plan, right? So how do we like quickly make some changes to make sure we are protected, right? But think about it, like this problem, or maybe like if you talk about the ransomware, right? So that was like also a big threat, right? But we were not aware of these things, right? We have the Trojans, right? Those are like pretty old stuff, right? So from the Greek mythologies, right? So Trojans are there, right? We are aware of this thing, and we are constantly updating ourselves, right? So that is the reason, that threats are needed at some point of time. The threats are needed so that we can transform ourselves, right? We can fortify ourselves a little bit better. We can look into the loopholes, right? So, I personally have seen that. Like say if I talk about the Log4j problems, right? So I have seen a lot of companies are taking a lot of extra steps to make sure like how they do their code scanning, right? So they do have the cybersecurity team, right? But how come they are not able to identify this problem, right? Because they were not aware that they have to scan their codes in this particular way, right? So when we talk about the code quality, we talk about the security of the code also, right? So we are training our developers to write more secure codes, right? And that is where DevSecOps comes into play, right? Why exactly nowadays we are hearing a lot about DevSecOps, right? So DevSecOps is the new DevOps. Okay, why is it like this? Because we want to apply or introduce the security as soon as possible in the development cycle, not at the very end, right? In a normal a scenario, what happens that you write your code, the developers, they make sure that they deliver a highly efficient or any highly performance oriented code, right? And then after that, we go for some security audits, right? And then maybe like if we are finding out some kind of security flaw or some kind of security bugs, and then we go back and then we ask the developer to fix it, right? And that usually extends the development cycle also, right? So if you implement the DevSecOps, it is also going to reduce the development cycle, right? That is also one of the big benefit what we get from the DevSecOps, right? So I personally feel, so companies are adapting, they're fortifying themselves, right? And at some point, this kind of chaos are needed, right? Like how you just gave the example of the EC2, right? So there was another big outage on Flipkart. The first time Flipkart gone for a big billion day, right? There was a big server outage, right? So they understood that, yeah, that's not right. That's not really working out. Okay. The architects and all, they thought about this is a pretty rigid architecture, but no, this also can fail, right? So it's at some point of time, it's required to remind you that you have to relook once again, right? So because at the end of the day, the people who are designing system, they're also human beings, right? They also have their way of looking into a system, right? So if you get to know that, yeah, so whatever I have built, what I felt it is the best, it is still having a loophole, let's fix it, right? And when you fix it, you're not patching it, it kinds of gives you an opportunity to rethink on your design, right? So one problem opens a lot of other problems also. So whenever so when I work on any architecture, right? So when I get any kind of loopholes in, like in the performance, in the scalability, in the maintainability, I don't just look into that module wherever I got a problem. I look into the other modules also, right? That if this problem is there in this module, it is definitely it will be there in the other modules also, right? So it gives a fresh perspective, right? And I'm pretty much sure companies are adapting, and it will be like this also going forward, right? So people will find out loophole, and companies will find out, the best way to fix it and to go
Yeah.
forward.
Fannie Mae is one of that institution. Chitra Elango was part of the team. The CISO was very confident about her, though she had a very horrible interview experience. She just got selected, and she was able to get that Apache struts done. Like, it was not having any sort of a compromise, and they didn't want anybody to have an access of their data. And that to me is an ultimate example of what security can come up in the world
Yes,
of DevOps. Like, to
yes,
me,
yes,
like, how fast can you adapt? That really matters a lot. How agile is your team? That also matters a lot.
yes.
Like capacity planning and everything. Yeah, yeah,
And
you can continue.
and, and you know what? So one more thing, that this actually forces a company to go for a process, right? Because a lot of times, so what happens, like so if you talk about some legacy projects and all that is running, right? But those are mission critical projects, but those are legacy projects, right? But you are not that reluctant to go for a major change, right? But if you are finding out these vulnerabilities, then that becomes a priority for the project. That irrespective of that whatever the effort that we have to give, we have to transform, we have to really upgrade ourselves, right? That's also one, trust me, a lot of projects like who are legacy, they don't are they're not that open for a change unless and until it is critical or it is a blocker, right? And this log4j was a blocker, right? So I'm just giving an example, right? So this is also, I would say, one driver which actually helps us to update.
Yep, that's true. And like, last question, I know this is off the record that we wanted to talk, but like, how is the capacity planning done when you're thinking about large scale scalable system? And we are now talking about like Kubernetes is doing its own job, but like, how can we really get that massive understanding of the requirements that we really want in our system? Like, hey, let's use Kafka, let's use this here, let's use that here. everything can't be added. It's just an added complexity. It's an added vulnerability to some extent. So how is capacity planning done in an organization? Of course, you have been in different organizations. So how is it all about today when we are thinking about capacity planning for the entire architecture that we are planning to do? So what is it all about?
Great question. So this actually varies from company to company, that how exactly you being a product owner or a project team, how you play the role of defining the capacity or your infrastructure. So how you define the infrastructure, right? So basically there are two different ways. Okay, so the first way, or so quite a standard way nowadays, is that so every company will be having their infra team, right? So what we call it as a SREs, right? The site reliability engineer. So whenever you are starting in a new project, right? So you first of all will have to find out the requirements, right? And this requirement is not only just a business requirement, you have to also find out the non-functional requirement. So in terms of so your performance needs, your the scalability needs, your user growth that you're planning, right? So what's the lifetime of the applications? All these things that you have to plan in the very beginning, right? And that particular thing is so actually at the project side, right? So that you have to plan that first. And I'm talking about the non-functional requirement. The functional requirement are the business requirement, right? And you also talk about the security, the authentication, how you want the authentication. You want a single sign-on at the enterprise level. All these things are being taken into the so in the consideration when the architects are planning for any architectures, right? And as you know, that architecture is basically a component level design, a high level component design, right? So when we go for a design, a system design, then we break down the component and we go for the individual component, that that the Kafka partitions, like how you want to use, how do you secure your Kafka, all these things comes under a component level design, right? So now I think the capacity planning is basically being done at a high level component design, right? And you take a lot of metrics into consideration, like for example, say the load, right? So you have to take the load as a first consideration, and then you also so take the example of like how so what is the application lifetime, right? So how long you want to run the application? Like say for YouTube, you want a continuous growth in the application, right? But in a lot of places, the lifetime is usually 4 years, 5 years, right? And that is the max growth, and you have to project that particular growth, right? So projections are not always accurate, but you basically project for 2 years, right? And if after that, so if you have to make some changes, you have to make some changes. And that is the reason we always say the architecture is what we build. It has to be modifiable, right? The architecture, you're not changing it, but you should be able to extend the architecture, right? So that's one of the very important consideration when we are designing any architecture, so building any say, architecture, right? So on basis of this, we create demands to our SRE team that say that, like for example, like the organization wide, we have got uh, a Kubernetes cluster, right? So we'll be telling that we are so building one backend application, and the backend application we would so having this kind of loads and all, and we would need this storage as a persistent volume, and this is my CPU usage, and this is my RAM usage, and this you give as a requirement to them along with the load, right? And then you basically have a so call with them, and they will also be telling that that how much cost, right? So you have to think about cost also. So capacity comes with cost, right? So how much cost, let's say if you are going for a 10 node cluster in a Kubernetes, right? So what is the capacity of each node? So if you're talking about in the EKS, right, or the AKS, right, the Azure Kubernetes Service or Elastic Kubernetes Service, so you will be using the pods as EC2 or maybe the AVM, right? Anything, right? So you have to like think about what is the exact node configuration you are taking, right? So you'll have to do a bit of cost planning also, right? The job of architects is not only just to design the architectures, and they also have to plan the cost, right? So they have to make a cost effective design, right? So those all metrics we basically take, and based on that we propose a kind of capacity, right? And with that proposition, we also so have a call with the SRE, and they also share their knowledge about their experiences, and they tell about that maybe with your workload, you don't need a 8 node system or probably 10 node system. You can go with the 8 node system. You don't need a 8 virtual core. You can go for a 6 virtual core, right? So like this, we have a discussions, right? And then we finalize so one particular deal, and that is what we sign off with the infra team. So So that is the case when you have a separate infra team, right? But there are multiple cases where the development team itself owns the infrastructure, right? In that case also the process are the same, the metrics are the same, right? But in that case, you will not be having that additional head to guide you. That, from my experience, I'm talking about the SREs, the site reliability engineers. Those guys are amazing guys, trust me. Okay, so these guys have seen too many applications, have dealt with multiple application performance issue, performance scalability, right? And to make the application high available, right? So they are having too much amount of knowledge on the infrastructure, right? So their knowledge really makes a big difference. But for the project who are not having that support of the SREs, they have to take the call by themselves, right? So in that case, the metrics are the non-functional the points that we have taken, and also the cost, right? So every project will be having a cost, right? We cannot be just open to the cost. That for performance, we are asking for that I need another 1 million. That's not possible, right? In a real-time scenario. Right? So these are all the factors, that what I personally have seen that which basically impacts the capacity planning, particularly on the resource side, on the compute resource, storage resource,
Anything,
anything.
that's
Yeah.
it. Yeah, I think that's the ultimate introduction to all the things about software engineering, data engineering, and everything that we talked about. You need not have to go any places. Just come here, the serious podcast. We have talked a lot. And I think thank you so much, Pritam, sir. We covered a lot of things. Of course, I missed some questions because you answered it in one question. Like, that's what it's all about. So when I asked you about capacity planning, you also talked about how the ALM is taken care about it. It's like, and I was just so glad that you're covering a lot of things in a short span of time. And thank you so much, sir. It means a lot when you share that kind of an insights on my show.
Cool. That's good.
Thank you so much, sir.